Hello and welcome to this first video on Practical 2. Since you're all master students, I'm going to assume that you can plan yourself and you know what you need. So this video is just to show you how I created the model that is provided to you in the CAE file. If you feel comfortable you can create this model yourself, please skip this video. If you're curious anyway, feel free to watch it. So I'm gonna go relatively quick in this case. We have a 2D shell, approximate size. Well, actually, I'll make it, well, 200 should be fine, but we'll see in a moment that it's not always what you expect. I start in the origin and just trial it out, and you see it is 200, but this one doesn't go to 100. So I'll have to resize it anyway, but that's no problem, because here we have a length of 100. And here we have a length of 75. And what I'm going to do now is not strictly necessary, but we can also translate it, and I want to move it. I want to have everything moved. I want this point to go to the origin. Not that it's a big deal when it's not, but I just like it when it's in the origin. Then to create the cutout here, what I know is I know the center and I know that the radius is 25 millimeters. So I'm going to use this option, create an arc using the center and two endpoints. So pick the center point, that's this one, then any point on XY. Now looking there on the top, I know it's 25 here, 25 here, and I'm done. And of course, if you want to be sure, you can always say that that should be 25, and then you're 100% sure it will not change, but not strictly necessary. Then use here the auto trim function that basically trims away anything you want, and I don't need these two lines because this is how my section should look like. And that's it, I'm already done with creating the section. Then the next point is creating the materials. So I have mechanical elasticity, let me call it aluminum, Young's modulus 70,000, Poisson ratio of 0.3. Okay, then I also need a section, solid, I call it an alu section, with a thickness of 3. Okay. Then in the part I have to assign this section, of course, so section assignments. This part, in this case, I don't want to create a set aluminium section. Okay. And now I'm going to create sets. And the reason I'm doing that, type geometry, because there are no nodes yet. So the left edge, because later on we'll see that we will, and bottom edge as well. And the reason that done. And the reason that I'm doing it is because we will be splitting up the edges. So if I select it after it is meshed, I will always have to redo the selection of the part. But if you have a set of the geometry, I can apply the boundary condition to the geometry, which will not change. And you can always change check by saying here bottom edge. You see it highlights in red, so this is the bottom edge, this is the left edge, so that went okay. Then we further work our way down. We don't have a profile, we do need an assembly. So part 1, yes. Then we of course need a step. It's a loading step, static general. Perfect, continue. Field output, history output requests, I'm not gonna bother with it at this point in time. Usually do check it, but in this case we're okay with the standard because the focus of this practical is on the meshing anyway. Then a whole lot of other things we don't need. Then loads we do need. And in this case, I'm gonna apply a surface traction load on the surface on the right. The vector is in x direction. Traction, well, you can still call it shear, even though it's not really shear, but it's the vector that is leading per deformed area. And actually I'm gonna keep it general because I don't want to follow the rotation. And then in this case you see the load is applied indeed to the right, and it's with a magnitude of 10 megapascal because it's on a surface. So you know the stress far field should be 10 megapascal. Then the boundary condition, in this case I'm going to use symmetric boundary conditions. I know we haven't discussed it quite yet, but I'm assuming that you know from your bachelor education what the symmetry and anti-symmetry conditions are. If not, we will discuss it in more detail in practical 4. So on the left edge here, cancel. I don't want to select the edge, but I want to select the geometry. And in this case, I want xsim. Then I want to have on the bottom edge ysim. Okay. And now there's one thing I forgot. The focus of this spectacle, I'll make it 7.5. Okay. And I also want to make sure that it's only quads, not quad dominated, but quad. And then I can say, okay, mesh part. And by the way, this was mesh controls, how I went to quad. Maybe that was a bit quick. So now we have the mesh, we have the boundary conditions, we have the loads, we have everything, so we can create the job. And I'll call this one practical to V1. Okay, because why V1? Because you will probably run more than one mesh. If you're interested, the main thing is on getting a good mesh this time. And I tried this before, so there's already a file called V1. Please realize that even though I do provide you the CAE file with this job, and it's completed already, the ODB file is not included, so you will have to submit the job yourself again, even though in the CAE file it will say completed. I'll save now, and this is the file that you will get. And the results, it's always nice to see them like this, and you can clearly see the stress concentration here. But how we can do the post-processing will be explained in the next video. Thank you.